All right, here we go. We left off last week. I asked you to do this problem, I believe, and the one before it for.
You asked us to do exercise 1 and exercise 2.
So I asked you to do these two?
Yes.
Okay. All right, so we're going to go through these and then head on to some other stuff, and then you'll be able to get 7-11 for homework tonight if I can. All right. Okay, so when we're looking at this, we've got copper bromide, copper 1 bromide. So that is the formula for that. And this is a solid. It's going to break down into copper plus 1 plus Br minus, some of it, okay? So they want us to calculate the KSP value given that the solubility is this. So when they give you this, this is the solubility of these as like single items, okay? So if you had this, like if it was copper 2, for example, and you had Br2 here, okay, this value would have to be doubled for the Br value. So this is the solubility for one of these formula units. Well, you will whenever you're calculating the KSP, but I'm talking about for the values that you're going to put in your ICE table. Okay. So this is your solubility. So that's going to be how much is going to come out when it's in for each thing here. Okay. So if this happened to be the molar solubility for this guy, it would be 2 times 10 to the minus 4. But this one you would have to multiply. So this would be 4 times 10 to the minus 4. That makes sense? Yeah, in a way. Yeah. They're talking about like the whole unit, you know? And so when you break it out, you've got one of these and you've got 2 of these for every molecule. So that's why you would have to double it, because there's going to be twice as many of these coming out as there will be this.
Well, for these questions, you don't need to do ice tables, do you?
No. But I'm just saying that, like, if it helps you organize it in your brain to try to figure out how to calculate the KSP. So your KSP is going to be 2 times 10 to the negative 4th squared, which ends up being 4 times 10 to the negative 8. That's your KSP value. Questions on that? You good, Miles?
I was just wondering for in the product side, isn't bromine a Brinkelhoff? So wouldn't it be 2?
No, it's not a Brinkelhoff. It's only when it's by itself in its pure form. This is an ion form. So this is going to be floating around in water as an ion.
Okay.
So it's not going to be like liquid bromine in a tank or something like that. This is an ion of bromine. And that's an often confusing thing for people. I just gave a test on that in regular chem, and that was one of the questions that came up. So that is a confusing concept. All right, so let's try to figure this guy out, considering what I just told you about what this means. No, I've got drink. I just need to actually do it. All right, so for Bi, we've got 2Bi 3 plus 3S2 minus. So that means we're going to have to take this guy, we're going to have to multiply him by 2. And then what do we have to do to that whole thing? Square it. Then we have to multiply that 1.0 times 10 to the minus 15 times 3. And then what do we have to do to that whole thing? Cube it. Right. And then we got to multiply all that jazz together. And when you do that, this is what you should end up with. Let's see if you can get that to come out on your calculator. How many calculators do I see out?
We did this one.
We did this one already? I asked you guys. And
We
you
did 1 and 2 on homework.
All right. Moving on.
Now,
Calculate the KSP value for this. No, this is the KSP value. Okay. So CuiO32 yields Cu, and that should actually be a two-way arrow. That's an ugly arrow, y'all. I'm sorry. There. Cu2 plus IO3 minus, but I've got 2 of those. So this is going to be X, and this is going to be 2X. So my KSP is going to equal X times 2X squared. 4X cubed. Okay, so 1.4 times 10 to the minus 7 equals 4x cubed. Divide both sides by 4, take the cubed root of this, of whatever that is, and x should equal, I don't know. Did you do that? Not yet. You're going to try that on your calculators? All right. Now I'm up to speed. Just a couple, no, 2. He asked how many decimals we should take it to, and I said 2 to 2. Because you had 2 here. So we're going to go 2 here. I have to kind of repeat this so Miles can hear, because he probably can't hear what you said. So that's why I'm repeating stuff. Calculate its solubility. This is the solubility of this guy. If you wanted to figure out the Cu would be the same amount, because you're going to get that many out of this. You're going to have that molarity for this guy. But when it comes to the IO3 solubility is going to be twice that. That would be 2x, which I think comes out to be 6.6 times 10 to the minus 3, if I remember my math correctly. All right, good. All right, so now we're going to hold this problem off until our discussion tomorrow. I think I'm going to open tomorrow with this problem, if you remind me. Oh, we will see. All right, so I want to come over. We've been talking about this stuff. It's just another way of them talking about it, but it's the same stuff that I've been discussing with you. I'm going to do a couple more problems together. All right. Get my comments on here so I can use my pen. Go. All right, so we've got a compound XBr3. They gave us a KSP value. They said when it's added to water, what's the concentration of X3 plus and the Br ions? Okay, so XBr3 is going to yield X3 plus Br minus 1, and I'm going to have 3 of those. So this guy is going to be X. This guy is going to be 3X. So then when I want to calculate this, it's going to be 4.52 times 10 to the minus 8 equals X times 3X cubed. So that's 27x to the 4th equals 4.52 times 10 to the minus 8. And when you're calculating that out, you've got to divide both sides by 27 and then take the 4th root of that value. And the way you get that on your TI calculators is you hit the math button. And I think it's 5 down.
Yeah, it's math.
It's math, and then 5 is the option. And it has like a little thing here, and then the square root symbol, and then another box here. And you're gonna, for this one, you'll enter your 4, and for this one, you'll enter whatever value this is divided by 27. And then hit equals, and that should give you the answer of, roll please, X minus equaling 0.0064 molar. And then what do I have to do to find the Br minus? I have to multiply it by 3, which ends up being 0.00, no, not 2 zeros, sorry. 0.019 molar. Were you able to get that to come out in your calculators? Is it making sense algebraically? All right. Anybody not up with me? We're going to start the next one. Haley's still writing. I'll wait. Let me know when you're ready, honey. I got time. We're good. Miles, you good, hon?
Yeah.
Okay. All right. I'm going to start the next one then. So the idea is that when we look at these, we need to see if a solid is going to form, okay, or if it's going to stay in solution. So remember, we have solid, and then that solid goes off into some sort of cation. So cation with a plus charge plus an anion with a negative charge. And in this case, we're going to try to see if we're going to form magnesium hydroxide and have these ions come out, or if this is going to be concentrated enough that we're actually going to form a precipitate, which would make it run in this direction. So we've got to figure out our Q value for this. And remember, K versus Q. If K is less than Q, then we will form a precipitate. So they're asking if a precipitate will form. We've got to figure out what our Q value is and see if that is less, or if the Q value is greater than K, then we will form a precipitate. So we've got to kind of do this jazz here, and then that'll figure it out. Because they gave us K, we know what that is. We've got to figure out Q and see where that's going to fall on this line. Okay. So let's go and do that real quick. So we have magnesium nitrate. So we're looking at the magnesium part of this because that's what we care about here to see what concentration that's going to be in the water. So if I have 0.12 liters, I took this and turned it into liters, and I multiply that by the molarity, that's going to give me my moles of magnesium. Okay. Now I'm going to do the same thing here. Which ion am I concentrating on? The sodium or the hydroxide? The hydroxide, because that's what's going to come over here and be my anion. So this guy right here, so I'm going to take him and I'm going to do 0.44 liters times 0.0045 molar. That's going to give me my moles of hydroxide. Is that what you got for your moles of that? All right. Now, let me caution you and say if we were actually looking at this guy instead, we would have to double this amount because there's 2 of those for every 1 formula unit. Okay? So I just want to kind of throw that out at you so that you're kind of aware of that. All right, so we have the moles of this. Why did I need to go all the way back to moles for these? Well, I need concentration. That's what I need for my Q value. But what happened to my concentration when well, look at what happened here. Is it the same concentration anymore? No. We've changed our volume here, so therefore our concentration of those things has changed, hasn't it? So now I need to go back here and I need to divide by my new volume. My volume is now 120 plus 440, which is 560. So 0.560 liters and now my concentrations have changed. So now I have, instead of my magnesium, the concentration was 0.1, it's actually 0.0214 because we added in a lot more liquid to that, didn't we? And this guy, he becomes 0.00354 molar. He was here. Now he's here. He's gotten more dilute because we've added more liquid in, haven't we? So now I can go and figure out my Q value. Everybody up with me so far? Have I lost anybody? Miles, you good?
Yep.
Okay. All right. So now I'm going to go back. I'm going to take my mg here. Oh, this should have been a 2 in front of here, by the way. I'm going to take my mg here, which is 0.0214. Then I'm going to take my 0.00354. What do I got to do to that guy? Square him. And then I'm going to calculate my QSP. Nope, we already know the moles. This is the molarity. This is the number of moles. So we do that if it's an X value. But we've already taken into account. No, we wouldn't have, because it was in a 1-to-1 ratio here.
Oh, that's if it's, yeah. Okay. Yeah, I understand.
All right, so QSP here, then I ended up with 2.68 times 10 to the minus 7. So K versus Q, which one's bigger? Well, we don't even need to look at the beginning numbers. We can just look at those exponents and be able to tell pretty quickly. This was a KSP of 10 to the minus 12. This is 10 to the minus 7. Which one's bigger? Right, this is bigger. So the reaction is going to run this way. If it runs that way, then that means that it's going to form more solid. So will it precipitate form? Yes.
Wait, is there a reason, like, the reason I asked that is because back in, like, exercise 2, we multiplied by 3 and cubed. It wasn't an x value, but here we did multiply by 2. That's where I was going.
Exercise 3.
Exercise 2.
Exercise 2.
It was in, like, the notes that we did before this.
Oh, that exercise. Oh, I thought you meant 7.2. Oh, okay.
We multiplied by 2 and squared.
Right, but they gave us, so exercise 2, they gave us the solubility factor. They didn't give us the molarity. Here they're giving us molarities and they're giving us volumes. So we have to figure out the so they were telling us, how do I explain it to you?
No, I understand. Is it because the other one they were only focusing on one equation and this one has multiple different components? So
yeah, and then this is a mixing of stuff. So, and before it was just like this one thing, yeah, you know? And so now we have to like take it down into its more, yeah, we have to go deeper, I guess.
Understand what you mean. It's because you're working with,
and you're changing the concentrations here. So you know how many moles you're dealing with. You don't have to double stuff anymore. You don't have to do any of that because they've already given you the raw data. Yeah. They've given you as deep as they can get you.
So if you were focusing, the difference between these two is that this one gives you the information for the milliliters and the molarity, so you can solve for the moles. Rather than the other one where it was just the equation and the solubility.
Yep.
I understand.
Okay. All right. So tonight, you guys are going to do these 8 problems on here, and then you're going to stop right here. And then tomorrow when we come back, we're going to talk about common ion effect. Okay? All right, Miles, you good, honey?